Great. To not lose too much time, I think we're going to get started. We'd like to welcome everyone to the third of our series, WASH Nutrition and Child Growth webinar. Today's webinar, as you can see in front of you, will be entitled Rethinking WASH Indicators to Understand and Address Environmental Contamination and Improve Child Growth. And we're really pleased to have a three-person panel from the Center for Global Safe WASH at Emory University. Next slide, please. So just to set the stage, I should introduce myself. This is Julia Rosenbaum. I'm speaking to you from FHI 360. I am with the USAID WASH PALS project, and we're one of the three co-hosts of this webinar. The hosts include the WASH PALS project, as I mentioned, Pro-WASH, and the Clean Fed and Nurtured Coalition. So this is the third and last of our three-part series. Our first webinar explored the evidence, as the name shows. We started the series looking at the evidence and interventions linking pathogen exposure via both human and animal sources. The second webinar really delved into some of the possible options for reducing infant and young child exposure to enteric infections, specifically to animal as well as human sources of enteric infection. And we looked at 3.5 different interventions. We looked at, excuse me, we looked at playpens, we looked at chicken cooping, and then we looked at a combination of play mats and cooping. In addition, we touched on improved flooring. And this third, and if we could go to the next slide, this third webinar really looks at measuring. We're looking at WASH indicators to understand and address environmental contamination and improve child growth. So, as we said, we started the series looking at the evidence of interventions. We started looking at the evidence that linked pathogen exposure via these human sources. And what we really highlighted is that there's a growing evidence that fecal assault on the gut will actually change that shape of the gut and the function of the gut, which weakens the ability to absorb nutrients, and it makes the infant much more susceptible to enteric infection. As you see here, there's a building consensus that we really need then to look beyond the impacts of pathogen exposure on child growth to move beyond diarrhea. So this session is specifically focusing on measuring enteric infection, and we'd like to give some insight and guidance. We'd be measuring for several reasons. There's the basic science that still is being established. And so there's a series of needs of measuring the actual impact of enteric infection on infants. There's also needs to plan and monitor our programming as we move forward to try and apply the new evidence base. And so we'll touch a bit on all the different needs to measure and some possible techniques for measuring, but we're really focusing here on the implementer perspective. So our webinar today with Sanipath really focuses on assessment to try and identify priority needs to develop an intervention, and then how to monitor and eventually evaluate the impact of that intervention. So with that, if we could get to the next slide, we're really delighted to have the Sanipath team. I'll turn to my colleague, Rebecca Pinto, who will give a bit of the mapping of the day, and then we can move forward with our presentations. Thank you so much for joining us, and it's really a pleasure to have you all here.
Thanks, Julia, and I apologize. It doesn't seem that this slide is advancing, so I'll just talk a little bit about the agenda for today and the run of events. We're going to have 3 presentations, beginning with Dr. Christine Moe, followed by colleagues from Sanipath. Suraja and Habib will be talking both about the Sanipath tool and how it's currently being adapted to rural areas. So we wanted to just acknowledge that even though we sent out the original announcement that this will be about 60 minutes, we'll likely go to about 75 with Q&A, but understand that many of you might need to drop off because of other commitments. All of the recordings, all of the PowerPoints, they'll be sent to you just after we finish, but they're also available via our website on the FSN newsletter, sorry, the FSN network, where you can also sign up for the ProWASH newsletter. Also, just to note that today's session is being recorded, and then you have two options to be able to share your experiences and questions with the panelists. We have a Q&A box, and we want to encourage you throughout this entire event to go ahead and submit any questions you have. The Sanipath team, the ProWASH team, and Julia will all be taking those questions and responding to them as we continue on. We also have a discussion box, and there'll be opportunities throughout this presentation where we'll be offering some discussion questions to all of you. We encourage you to share from your experiences of your organizations in this box. And with that said, I'm going to go ahead and turn it over to Christine and the Sanipath team to begin their presentation.
Okay, good morning, good afternoon, or good evening. My name is Christine Moe, and my colleagues and I are very pleased to have this opportunity to speak with you today. And I want to start by thanking Julia Rosenbaum and Rebecca Pinto for inviting us to give this presentation on our Sanipath work on examining exposure to fecal contamination. And we look forward to your feedback and your questions. And of course, the garbage truck is right outside my door, so sorry for the noise. Okay, next slide, please. So we are dividing our presentation into 3 parts, and we will have some poll questions and discussion questions posted in the chat box during each part. I will start by giving an introduction to exposure assessment and why we have focused on this. And my colleague Suraja will then explain the Sanipath tool that we have developed and deployed and show you some results from different urban settings. Then my colleague Habib Yakubu will describe more about our findings on how children are exposed to fecal contamination, how we have been adapting this exposure assessment approach for rural settings, and finally, how these results are being used to inform interventions, investments, and policy in Ghana. Next slide, please. So as a researcher who focuses on water, sanitation, hygiene, and enteric diseases, I've been thinking about how people are exposed to fecal contamination for many years. And I want to start by making a few fundamental observations. Next slide. First, we know that excreta is often not contained. Many of you have probably seen this type of shit flow diagram before that looks at the various steps along the sanitation chain, from containment to emptying, to transport, to treatment, to reuse or disposal. This particular example is for the city of Dhaka, Bangladesh. And at each step during this chain, excreta may be safely managed, as shown by the green arrows, or the excreta, which may contain hazardous pathogens, can be accidentally or deliberately discharged into the environment, including the residential environment, drainage systems, and surface waters. Our exposure assessment work and the Sanipath tool focuses on the leaks in the system. What happens to the 98% of excreta or fecal sludge that is ineffectively treated or not treated at all prior to being released into the environment? Where does it go? And how do people get exposed to it? What are the public health risks from having excreta in the environment? And what do public health authorities need to know in order to effectively intervene and protect public health? Next slide. We recognize that inadequate sanitation leads to multiple pathways of exposure to fecal contamination. As we think about fecal contamination in the residential environment, we realize that there are many different types of exposure pathways, or you may think of them as transmission routes for pathogens. Most of you have probably seen some version of this F diagram before that shows the sources of the pathogens in human and animal excreta, how these pathogens enter different compartments of the environment, and then how food and drinking water and hands become contaminated with fecal pathogens and serve as vehicles for transmission to other humans. These photos in the next slide illustrate examples of these various exposure pathways that we have seen in our study settings. And these may look like the places where you work. So we know that floodwaters can carry fecal contamination from open defecation or open drains. Public latrines can have fecal contamination on the floors or the walls where people wipe their hands. Open drains may have wastewater with high concentrations of excreta. Ocean water and surface water may receive direct discharge of wastewater or fecal sludge, or they could be contaminated by open defecation in or near the water. Street food can have ingredients contaminated at the farm, maybe from animal manure, or it could be prepared by hands that have fecal contamination. We know drinking water can be contaminated at the source or after treatment in the pipes network, or contaminated from the jerry cans that are used for transport or storage. Same with bathing water and produce or wastewater irrigated produce that's eaten raw, like lettuce or tomatoes, that can become contaminated if they're irrigated with wastewater on the farm or rinsed with wastewater at the marketplace. We know that soil can contain fecal contamination from animals or humans. And finally, fomites or objects become contaminated from contact with dirty floors or dirty hands. So multiple pathways of exposure. In the next slide, we know as public health practitioners, we're trying to develop and implement interventions that aim to block these pathways. So interventions like sanitation may contain human feces and prevent contamination of the environment, but it will not address animal feces. But we think of sanitation as an upstream intervention. Other downstream interventions are closer to the point of exposure, such as improving the quality of drinking water, or improving food hygiene, or improving water accessibility and promoting hand washing. Next slide. So when we implement these sanitation interventions, we hope or expect that the intervention is containing excreta, and that this will lead to a reduction of fecal contamination in the environment, then less exposure to fecal contamination and enteric pathogens, and that will result in less diarrheal disease, less helminth infections, less environmental enteric dysfunction or EED, and less stunting. Next slide, please. But is this really what happens? We know from the disappointing results of several recent intervention trials that the expected health benefits were not observed. Did these trials actually reduce exposure to fecal contamination? Or did they reduce exposure enough to make a difference? So the Sanipath tool focuses on these two center boxes. We focus on exposure assessment. Next slide, please. So from our research, we've come to think about the F diagram somewhat differently because we have detected fecal contamination in many parts of the environment. We think that children may actually be surrounded by fecal contamination in their environment and often come into contact with fecal contamination in their daily lives. So Sanipath focuses on these different environmental pathways in the public domain, and our understanding of these pathways is based on in-depth research that we conducted in Ghana, and this has been further refined through multiple deployments of the tool in different settings, as you will hear from Suraja. Next slide, please. The goal of our exposure assessment is to identify which fecal exposure pathways are in a specific setting and the relative importance of these pathways in terms of their contribution to total fecal exposure. In the top diagram, we see a hypothetical situation with 4 fecal exposure pathways. And the combined exposure to these pathways is the total dose of fecal contamination that a child is exposed to on a daily, weekly, or monthly basis on the x-axis here. As the dose increases, we expect the burden of enteric infection increases, as shown on the y-axis, until it reaches a point where there is so much fecal contamination that there is a saturation. The child is at a point where they are always exposed to fecal contamination and may experience a high burden of enteric infection or disease. One key point to note here is that not all the pathways are contributing equally to exposure to fecal contamination. Some pathways may be minor contributors to fecal exposure, either because they're not very contaminated or the child is rarely exposed to them. For example, in pathway A, in a specific setting, maybe this is floodwater exposure. Interventions that are targeted to this pathway may reduce the cumulative exposure to fecal contamination, but not enough to make a difference in the health outcome. You don't see a change along the y-axis. However, if we could identify and successfully intervene on a major exposure pathway, like what we see here in pathway B, then the cumulative exposure to fecal contamination would be significantly reduced, and we would expect to see a corresponding reduction in the burden of enteric disease on the y-axis. So next slide, please. We're going to move to a couple poll questions. Number 1, should we be placing equal importance on each of these pathways? And number 2, which of these pathways are you currently addressing as part of your work? You may want to indicate in the chat box which pathways you think are the most important in the settings where you work. So we've got about 53%, 53% of people voting. Want to give time for everyone to get their answer in. Okay. So maybe we should move on. We've got 60% of the vote in. So what do we see here? Is there equal importance on each of the pathways? 22% of you said yes, and 78% said no. Which of these pathways are you currently addressing as part of your work? We see that most people are addressing drinking water, 85%. Most people are also addressing latrines, 64%. and then less attention focused on some of the other pathways. Looks like soil and sand comes in here as maybe number 3. Okay, good. And please indicate in the chat box if you have an opinion about which pathways you think are the most important. And let's move on to the next slide, please. So I want to spend a moment talking about how to measure fecal exposure. And it's important to realize that exposure is really the interaction between the fecal contamination that's in the environment and a child's behavior that brings them into contact with this fecal contamination. So it's an interaction between contamination and behavior. Where in the environment is there fecal contamination, and what is the magnitude of that contamination? So we can measure that by collecting environmental samples. And it's possible to measure pathogens in environmental samples, but this is expensive and it requires advanced lab capacity. So as you will hear from Suraja, we focus on measuring fecal indicator bacteria, specifically E. coli, which is feasible by simple field methods. The other thing we want to know is how are people coming into contact with fecal contamination? Who is coming into contact? We know adults and children behave differently, and also there may be different behaviors for males and females. Also, what type of behavior are we looking at? Is it deliberate ingestion of raw vegetables or drinking water or street food? Is it accidental ingestion of surface water or bathing water or animal feces? Or is it contact with open drains or flood water or latrine surfaces? And how often do these contacts happen? Next slide, please. By identifying all the fecal exposure pathways in a specific setting and measuring the magnitude of exposure, we can better understand which pathways are the most important or the dominant pathways. Next slide. Here we define dominant pathway as those that make the greatest contribution to the total fecal exposure. The figures on the right show that the pathways can contribute differently to total exposure for a population. And the amount, the amount of reduction to total exposure when a particular pathway is removed. The top image shows the expected minor effect on total fecal exposure by removing pathway A, a minor pathway. But in the bottom image, we see that the total exposure could be substantially reduced after removing a dominant pathway like pathway B. Next slide. We also need to understand what are the drivers of exposure. Is a specific pathway dominant because it happens nearly every day, such as consuming moderately contaminated drinking water? Or is it dominant because the magnitude of fecal contamination is so high that even occasional exposure is enough to cause a high probability of infection and disease, such as contact with open drains that carry concentrated wastewater and excreta? When we understand the dominant pathways and why they are dominant, then we can more effectively develop interventions, programs, and investments targeted towards these dominant pathways in order to reduce exposure and improve public health. Now, I'm going to turn the presentation over to Suraja to explain more about what the Sanipath tool is and how it works. Suraja, over to you.
It's Christine. So I'll now be giving a brief presentation about the Sanipath tool, which was, as Christine mentioned, developed by our team at Emory as a simplified yet standardized method of conducting exposure assessments. This tool was developed after doing in-depth exposure assessments in Accra, Ghana, and realizing that replicating that effort was both time and resource intensive. So this is our way of trying to make this type of exposure evidence more accessible to stakeholders to inform programming. So the Sanipath exposure assessment tool is designed to assess public health risks related to poor sanitation and fecal sludge management, raise awareness about these risks among stakeholders, and help prioritize sanitation investments based on the exposures that have the greatest public health impact. The tool was designed to be used in urban settings. However, exposure thinking is applicable in rural settings as well, and my colleague Habib will be talking about that a bit more and how exposure assessment can be applied to a rural setting after me. The Sanipath tool focuses on these 9 pathways of transmission from public or shared spaces. These include street food, drinking water, surface waters, open drains, public latrines, flood water, bathing water, and raw produce, as well as soil and sand as in background fecal contamination. All data collection activities when using this tool are aligned with these pathways. This tool outlines a standardized and simplified method for data collection. The process of using the tool protocols are outlined in this diagram. It starts with a preliminary assessment to better understand the context and customization for the tool and guide the main behavioral and environmental data collection. So based upon the local context, the tool can be customized. The behavioral environmental data collection is conducted, and then risk profiles and summary statistics can be generated, as well as a final report, and I'll be talking about that in further detail. There is a Sanipath tool interface, which is used to manage data collection, analysis, and reporting, and all of that is automated, and I'll also be describing that. The tool collects 2 kinds of data: behavioral data and data on environmental fecal contamination. Data on behavior are collected using surveys of reported frequency of specific behaviors of adults and children that may lead to exposure to fecal contamination. For example, what types of water people may drink, the frequency of contact with which they have with pathways like open drains or public latrines. These data are collected through household surveys, as well as school and community surveys. And the school and community surveys are administered through a group voting method. Data on the locations and magnitude of fecal contamination in the environment are collected by taking samples from each relevant exposure pathway and analyzing these samples for E. coli, a common microbial indicator of fecal contamination. These data are then combined to estimate the relative risk of exposure to fecal contamination. We have really tried to design this tool to balance resource and logistical constraints with providing valuable exposure data. So these pictures from the field show how users have been able to adopt mobile data collection and conduct surveys easily in the field. I also want to take a moment to briefly address the laboratory component of conducting a Sanipath assessment. In our experience, this is often something teams are intimidated by if they have limited laboratory expertise. However, we are here to reassure you that there are relatively simple and cost-effective ways to quantitatively test for fecal indicator bacteria. The Sanipath methods were developed for use with 2 simple methods: the IDEX quantitary method, which is pictured on the left, and the membrane filtration method, which is here on the right. Most clinical and environmental microbiology labs, for example, labs in hospitals, ministries of health, or wastewater and water treatment facility labs, have existing capacity to do these analyses. So here are some pictures of collaborators collecting and analyzing samples, for example, drains or swabs of public latrine surfaces. I also want to point out the picture showing the process of analyzing the samples via membrane filtration or the IDEX method. Some of these E. coli assays are quite portable, and actually this picture in the top right-hand corner shows how for some of our field work, our team has actually set up a lab literally in a hotel room, so it is possible. I want to show how the data from each part of the study is combined to provide an estimate of exposure for a population. So behavioral data from the household, school, and community surveys are combined with environmental data from the laboratory analysis of samples, along with parameters from the literature and other studies that give us an idea of intake volumes. For example, how much on average a child may consume drinking water in a day, and the duration of exposure. For example, how often someone may go swimming in a surface water. So this is combined using a Bayesian analysis to provide an estimate of the dose of exposure and percent exposed in a population. The result are these people plots featured in the center, which show exposure through two different components. The percentage of people exposed, which is shown as the number of red people in the plot, and the dose, or the concentration of E. coli ingested per month, which is depicted by the darkness of the red color. So this slide highlights the people plots a bit better and shows the way exposure can be compared. Here within a single community, we have 5 different pathways that can be compared with this standardized data. And you can understand the relative risks of these pathways to each other. For example, because of the very faint light people, which you may not even be able to see on your screen on the public latrines people plot, you can see that the dose due to exposure to public latrines is relatively low compared to the other pathways. You can also see that drinking water and flood water have a much higher number of people exposed, percent of people exposed, than produce and public latrines. These pathways can be compared across a single neighborhood, or you could compare a single pathway across multiple neighborhoods. The tools and protocols and the guidance for using the tool are all open source and freely available on our website, sanipath.org. And the platform is accessed at tool.sanipath.org and is where users can go to select the appropriate pathways for the local context and customize their assessment. So you can customize the mobile data collection forms, which are collected through Kobo Collect, and this includes the behavioral surveys, environmental sampling, as well as where the laboratory data would be entered. And then all data are uploaded to a server and data repository on the Amazon Web Service Cloud. These can then be monitored and analyzed from a dashboard, and users can auto-generate these people plots, histograms, and pie charts, as well as a report, a final report, with general background and guidance for the interpretation of results. The links to their website, as well as our GitLab page, where the source code for the tool is located, will be provided to you all. The purpose of this tool is to guide users through a simpler exposure assessment that can still provide meaningful results where in-depth exposure assessments may not be possible. And as with any tool, there are strengths and limitations. So one of the strengths of this tool is that it really is an innovative quantitative analytical approach that considers multiple of these exposure pathways. And it also guides users in the collection of primary data. All of the training materials are freely available online, and it's customizable and open source. We've developed these web-based tools for management and analysis of the results as well. We've spent time with the graphics, had different groups of people take a look at them to make results easy to interpret and communicate to stakeholders. And lastly, this is a relatively rapid process, and real-time results and reporting is possible with the use of this tool. There are some limitations challenges as well. For one, the tool does not account for changes over time. For example, if you would like to see seasonal changes in exposure, you would have to conduct this assessment multiple times in different seasons. It also relies on self-reported behavior in these surveys. At this time, risk mitigating behaviors, for example, hygiene for hand washing or food preparation, are not considered in the model. And the model is currently primarily designed for urban environments. But ongoing adaptation is happening for rural contexts. It does require some level of basic laboratory and survey capacity, so this is not a tool that can be used entirely by sitting behind a desk. And as a result, you also need community cooperation and access to communities that you're interested in getting this type of information for. So we have a discussion question now, which I believe will come up in the chat box. What do you feel are some barriers or challenges to using this tool, and how might we address them? So we'll let you start having that conversation, and I'll move on to the presentation, but we'll have a chance to discuss your responses later. To this date, the Sanipath tool has been used in over 48 communities across the world, which you can see on this map. Not pictured on this map is Durban, South Africa, which is in the middle of an assessment but had to pause due to COVID-19. So with data from 10 different cities, you can start to see trends across the different communities. This graph compares child exposure data from 10 different cities. At the top, you can see the different cities where the assessments have been conducted. The x-axis lists the neighborhoods within these cities, and the y-axis lists the total exposure on a log 10 scale. On the right is a legend with all the different pathways depicted on the graph. You'll notice that raw produce, which is shown by this teal color, as well as street food, which is this burnt orange color, are dominant pathways in many of the communities. So you'll notice a lot of teal happening in these graphs, as well as this orange color. Since many of you may work at the intersection of WASH and nutrition, this is an important message on the role of food safety that it can play in public health. And as we, as a WASH community, as a nutrition community, are able to collect more data on exposure, we can be able to identify trends like these better. And so at this point, I will pass the presentation on to my colleague, Habib Yakubu.
Thank you, Suraja. I'll now talk about some of our results related to infants and young children from urban slums of Accra, and how we have adopted Sanipath methods to rural settings of Ethiopia, specifically in Haramaya region, and how results can be used to inform programming. Next. Children can be exposed to fecal contamination through various pathways in their environment. In many parts of the world, children live in close proximity to domestic animals, both in urban settings and especially in rural settings. And exposure to animal fecal contamination in the environment may be a common risk. These pictures are examples from rural settings. The picture on the top left show possible direct exposure through cow feces, and the bottom left through chicken feces. The picture on the right show possible indirect fecal exposure through mouthing play items that has been exposed to the nearby soil. Next. We have conducted over 500 hours of structured observation of children less than 5 years in urban Accra, and looked at what activities young children commonly do and where these activities occur. Our results show that children spent about 60% of their time on the ground, including dirt floors. They also spent majority of their time either playing or eating. These observations are also likely true for rural settings. And of note is that we rarely observed hand washing. Next. Using our structured observation data from urban Accra, our analysis and modeling for children less than 5 years shows the pivotal role of hands in transmission of fecal contamination. Everything goes through the hands, from touching the floor or soil with your hands and directly to mouth, or ingesting food either directly to mouth or indirectly from the floor to hands and then to mouth. The red circles represent different parts of the domestic environment where the hands pick up contamination. The green circles show bathing and hand washing, which remove contamination from hands. The arrows show how fecal contamination moves from the environment to the hands and then to the mouth, which is represented by the purple circle. We also collected hand rinses from young children and tested these for E. coli. These hand rinse data confirmed that children's hands frequently had fecal contamination. Next. The key takeaways from the Accra study were: 1, we detected widespread fecal contamination across the domestic environment, from concrete floors and soil where children played, to surfaces such as toys, spoons, and items they frequently touch in the environment. The second takeaway was that children spent a lot of time on the ground, as I mentioned previously, and we rarely observed regular hand washing of children. These observations and analysis led us to conclude that children have the greatest risk of exposure to fecal contamination when sitting on contaminated ground, eating contaminated food with their contaminated hands. Next, we have now adopted the Sanipath approach to a rural area in Ethiopia, specifically Haramaya. In contrast to urban environments, there are a lot more animals, primarily livestock, and the feces they generate in the rural domestic environment. Some rural folks keep livestock within their homestead. In addition, there are more untreated water sources used for drinking water. Young infants and their caregivers are likely to come into contact with feces in the domestic environment due to more time spent home with livestock and more time spent on the ground by infants as they grow and become mobile. So we have a discussion question for all attendees. What additional pathway or considerations can you suggest for adapting this exposure assessment approach to rural settings? And you can share this in the chat box. Next. The adapted Sanipath framework from rural Ethiopia takes into consideration how the child is exposed to fecal contamination at various key stages of life. Children aged 1 to 3 months who are less mobile, not crawling, and are carried most of the time at the back of their mothers are exposed differently than when they become mobile. The sources of contamination at these ages are primarily through feces and livestock. Primarily through feces from livestock and exposure to both the child and the mother or caregiver's feces. The key pathways of contamination from animal and human feces are through, as you can see in the second box, fluids fed the child, the floor, yard, where the child plays or is placed to rest, the fingers of the mother or caregiver, and fomites such as feeding utensils. The various arrows show how the child ends up ingesting feces through his or her hands and through breastfeeding, if no mitigation measures are taken to reduce contact with the various sources of fecal contamination. And of note, I want to talk briefly about breastfeeding, how a child can ingest feces through breastfeeding. And the most possible way is through the unwashed hands of the mother who touches the breast and the child feeds on the breast. So that's where you get the contact. Next. When infants begin crawling, become more mobile, and begin eating weaning foods from the ages of 6 months to 9 months, their fecal exposure pathways are increased by additional direct contact through soil and food. Using this framework, we are now able to estimate exposure to fecal contamination in rural settings of Ethiopia by collecting information on the frequency of behavior related to these pathways and their associated environmental samples. Next. The value of the Sanipath approach is useful for supporting evidence-based advocacy to guide sanitation investments. The risk profiles show fecal contamination within a single neighborhood or village or across neighborhoods and villages. These risk profiles are useful communication tools to engage local decision makers. The information generated on geographic and pathway differences can be used by health programs to effectively target areas of greatest risk to ensure maximum public health impact. Next. Ghana is a case study on a deliberate process of how we are moving evidence to action. Firstly, we are disseminating results by creating demand and awareness through media and institutional engagements. We are partnering with local authorities to generate evidence by involving environmental health officers and local utilities in data collection to ensure transparency and ownership of results. The evidence generated is then used to inform decision-making and action. The picture on your left shows the Kumasi Metropolitan Assembly, KMA, which recently won a grant based partly on Sanipath-related activities from David. Next. The picture on the left The pictures on the left show some of the various means we have engaged media in the dissemination of results. Primarily, we are engaging major TV and radio stations as well as print media. On the left are clippings of TV interviews and newspaper headlines generated from some of our media engagements. To engage institutions, we hold key stakeholder meetings to share results. The picture on the right is a meeting of key stakeholders from the Accra Metropolitan Assembly. Next. There have been some short-term and long-term decisions and actions taken by local authorities. Based on the evidence generated by the Sanipath deployments in Ghana, some of the immediate actions taken include engaging the water utility on challenges with water quality results in slums, hygiene behavior change education in local schools, and the immediate shutdown of a public toilet that was dislodging directly into a local river. Some of the long-term actions taken are focused on planning and policy interventions. For example, the Kumasi Metropolitan Assembly, which is the biggest second city in Ghana, and our local partners are using a £400,000 deferred sanitation grant. They won partly based on Sanipath evidence to develop and implement a food safety and quality compliance intervention. In addition, Sanipath is now a recommended planning tool by the Ministry of Sanitation and Water Resources in Ghana. Next. At the municipal level, the Kumasi Metropolitan Assembly has taken some policy actions. The figure you see is a portion of the Kumasi Metropolitan Assembly sanitation plan for this year. All the yellow highlights are plans and interventions developed from the evidence generated from Sanipath. Some of the interventions include developing standard protocols to guide street food vending, and public sensitization of food hygiene through media outlets. Next. At the national level, the Sanipath results are leading to ongoing policy changes. The National Urban Sanitation Strategy will now incorporate wastewater irrigated produce as a key pathway to address. All these policy and investment changes have taken several years to bear fruits. Influencing policy and investments takes concerted efforts of key stakeholders, the right environment, and committed leadership. Next. So you could see, we've been working with various organizations, and our work was supported by the Bill and Melinda Gates Foundation and several local authorities across the world and several partners we acknowledge on this slide. Please visit our website for additional information or how to download the tool. And we have some questions that if you would like to chat more about. How can we better use data gathered from tools like these to inform our on-the-ground interventions? What other tools or studies have you used to measure aspects of EED or fecal transmission? And what have you learned from them? Thank you.
Great, thanks so much to Habib, Suraja, and Christine for those excellent presentations. I want to encourage those on the call to keep thinking about these discussion questions, the ones that Habib have just offered up, which is how you would use these data to inform your project's approach, but also some of the earlier questions from Christine's presentations about the barriers that you really see to being able to use a tool like Sanipath or other tools as part of the work that you're doing. I want to offer up a few of the questions that we received both in the Q&A and the discussion box and open it up to Christine, Suraja, and Habib just for a few of their thoughts. One of the first questions we actually received from Bushra, which I think is great, is how does this relate to the other assessments that WASH teams undertake? Does Sanipath complement these, or does it actually include part of these assessments? If one does Sanipath, they don't have to do other WASH assessments, for example, on latrines and water quality. So I just wanted to put that to the Sanipath team.
So thank you. That's a great question. And I think, of course, it depends on what's the purpose of your assessment. What is it that you are trying to understand from the assessment? So Sanipath does include microbiological testing of drinking water quality, as you saw from Suraja's presentation. We also look at where is there fecal contamination in a latrine, but we don't assess the infrastructure. So we don't look at how that latrine was made or if that latrine is functioning. We do ask questions about whether people are using a shared latrine or a public latrine in the behavior side of the data collection. So I think my answer to the question is that some of what is in Sanipath may be similar to other WASH assessments, but it depends on the WASH assessment and the purpose. But thank you for that good question.
Thanks, Christine. Habib, this question is for you. I know that you touched on it in a few places in your presentation, but many of the partners that we work with at USAID Food for Peace work in particularly rural settings. And I'm wondering if you'd be able to provide a few bullets in terms of how Sanipath could be adapted to provide information on these settings, and then potentially what you expect to see different between information coming out of these settings versus somewhere like Accra.
Yes, thank you. Because in the most rural areas, they, especially women, they usually stay home with their children, and usually they have homesteads where they have livestock and stuff around. So, which is quite different in urban settings. You don't see, for example, in Accra, you don't see a lot of animals and livestock living with a lot of people. So that is one key area in terms of how people come in contact with animal feces. I think that'll be different. That will likely see a difference in that compared to somewhere in Accra.
Thanks, Habib. Question for the team coming from Laura Kwong, sort of a two-part question. What explains the extreme variation between cities? And is this truly reflecting extreme variation in exposure, or more a matter of variation due to small sample sizes? So that's the first question. And then asking a little bit about what steps have been taken to validate the results from the survey data, and does it truly represent children's exposures?
Suraja, do you want to tackle that one? Because I'm working on one of the questions in the Q&A box.
Sure. Okay, so the first question, I believe, was about the variation between cities, right? So Rebecca, remind me, was it what is the difference in exposure due to small sample size? Was that the question?
Yeah, I can repeat the question, Suraja.
Yes.
What explains the extreme variation between cities? Is this truly reflecting extreme variation in exposure, or more a matter of variation due to small sample sizes?
Okay, so the required or the recommended number of samples for a Sanipath assessment is 10 samples minimum per pathway. We do encourage groups who are conducting the assessment to collect more samples if their resources allow for it. Collecting more samples gives you more information, and that's better. But we have also, in our analysis, tried to take into account this variation within the samples in our recommendations. So for example, some samples or some sample types experience more variation. For example, we see not that much variation in drain water samples compared to something like produce, or maybe, and depending on the setting. So it's possible that sample size can have some effect, but I think that based on the data that we see in the exposure, that we have sort of tried to account for the variation within these different pathways. Christine, did you have anything to add to that one?
I think that sounds appropriate. I mean, we think that exposure does vary neighborhood to neighborhood. There are some exposures that we will see all across the city. For example, it's interesting that we find street food is a substantial risk in both wealthy and poor neighborhoods, whereas other risks tend to be more common in poorer neighborhoods.
Thanks both. The follow-up question for Laura was in terms of the validating the results.
Okay. So we've done a couple different types of validation. So one type of validation that our team has done has been in sort of the replicability of the results. So conducting the Sanipath tool, having two separately trained teams conducting the tool side by side within a single community. And this is to sort of understand how much variation there may be due to just different people collecting data, or during the same time, or just from sample to sample. And what we did find from that exercise was that this same dominant pathways were identified. And so it's important to recognize that with Sanipath, the main thing that we're trying to identify is those relative risks and those dominant pathways. It's not really designed to give you very granular detail on differences or minute differences between pathways. So we were able to confirm that this is a replicable process. The other types of validations that we've done have been looking into, again, sort of the effect of the variation of sample size, both on the, especially for the samples, to understand by using results from that in-depth study that we did, and kind of modeling what would happen if you took fewer samples, and if we're able to get the same dominant pathways identified if you did not take as many samples as if you would have in a big study.
Thanks so much, Suraja. We have a question from Lee talking about breaking down the data from Sanipath across socioeconomic levels to potentially understand what changes in habits or infrastructure that are important as SES rises. Wondering if you had any thoughts on that.
Habib, you have done this work in different neighborhoods with different socioeconomic status. Do you want to talk about that?
Sorry, I missed that question again. Can you please repeat that?
Could you please repeat the question, Rebecca?
Sure, no problem. So Lee's question is, do you have data across a spectrum of socioeconomic levels in the same city? He says, I think it would be interesting to look at the positive deviances among socioeconomic levels to potentially understand what changes in habits or infrastructure are important as SES rises.
Yes, so we've done a couple of these because initially we actually focused on just urban slums. And there was a lot of interest from stakeholders like, what's going to happen with people who are living in high-income communities? For example, with produce, everybody goes to the same market. Regardless of where you live in the city, you go to the same market. So exposed, you're not exposed differently from somebody from the urban slum. So we've done this in several cities. And yes, you see differences in all the different pathways in terms of exposure. But what we found was that produce especially, no matter where you live, the exposure was the same.
Great, thanks Habib. So one last question, and I think a concern that's sort of being expressed in the Q&A box, just around working with donors to be able to adapt this to different contexts. And Kimber brought up an interesting point, saying, one barrier for them would be convincing donors that understanding pathways at this level of specificity is required, as they might prefer to put funding into something like hygiene side interventions, hand washing or water treatment. Wondering if you have any thoughts on that, or how, based on your experience working with INGOs, how they've sort of worked with their donor on adapting the Sanipath and bringing that into their program design.
So that's a great question, and changing practice, changing business as usual is a big challenge. So our goal is to show different groups that it is possible to collect evidence, to make evidence-based decisions. I think a lot of times WASH development is done using some of the same assumptions that may not always be true in all places. I mean, yes, we need better sanitation, and yes, we need good drinking water. But I think trying to understand where are the main risks coming from in terms of transmission of enteric pathogens is really important. So when we started this work, we were WASH researchers. We are WASH researchers. And yet, in so many different neighborhoods, in different cities, we have seen time and again the importance of food contamination, produce contamination, street food contamination. And we know that these are linked to poor sanitation and poor hygiene practices, but we have to really understand this better in order to make effective interventions. So I think I've been in this field for over 30 years, and I think that it's really critical that we don't continue to do business as usual when some of the evidence suggests that business as usual is not effective at cutting some of these exposure pathways or transmission routes. We really need evidence to show us what are the important transmission routes in specific settings, and then understand how can we effectively intervene? Is it through behavior change? Is it through infrastructure changes? How do we reduce the fecal contamination? How do we prevent exposure to fecal contamination? So I really would urge all of you to think carefully about your work and how this type of evidence can help you design more effective programs in what you do.
Thank you, Christine. Just a quick follow-up for that. It seems from the results that you've been able to share and from what you've just said, this is a real call for being able to share these kinds of results beyond sort of the usual set of individuals working in WASH, and engaging our colleagues across agriculture and livelihoods and resilience and nutrition. And I'm wondering if you have any examples from your work with Sanipath in terms of how INGOs have been able to use this information to execute more effective multi-sectoral programming.
So thank you. That's a good question. And I would say at the moment that most of our relationships have actually been with municipal authorities rather than INGOs. And Habib and Suraja, you can correct me here, but I think what tends to happen, for example, we've worked closely with Kampala Capital City Authority. We've worked carefully with the Lusaka City Council. And these municipal authorities are excited about the Sanipath results. The example that Habib showed with the Kumasi Metropolitan Authority, they are using these results on a municipal level to change practice, to take short-term actions, as Habib explained, but also incorporating this into policies on a municipal level. So most of our experience has been at that level. For example, with Lusaka City Council, they were battling cholera in Lusaka. They were really excited to see the Sanipath results that showed them that shallow wells in Lusaka were a major risk factor and that they could focus their resources on trying to interrupt that transmission route through contaminated shallow wells. So I think that we would love to see international NGOs using this approach, using this type of data to help them also design more effective programs. But at the moment, most of our experience has been working with municipal authorities. Habib or Suraja, do you want to add anything?
Actually, we've worked with, we have an example of working with an INGO. We've worked with GIZ.
Thank you.
In Zambia, and GIZ was working hand in hand with Lusaka City Council. So we've had that experience with an INGO who was interested to use this, and they've used it in their programming in Lusaka.
Right, and WaterAid actually also used the tool in Siem Reap, Cambodia. And so they have disseminated results and tried to share it with other stakeholders in the WASH sector. So that in terms of action less far along than, for example, the examples in Zambia or in Ghana, but you know, there are INGOs who are thinking about this as well and trying to kind of think along and you know, sort of think about their programming with this exposure mindset.
Great, thank you to everyone. I think we have time for one last question, and I'm going to offer the question to Habib now that we have you online as well. I noted that you wanted to answer this question live from Kyla. Is Sanipath collaborating with other researchers also working in similar efforts and across other contexts? For those of you that were able to join the webinars that preceded this, we've had presentations from Christine Marie George at Johns Hopkins, and a number of others. And so just wondering if Sanipath is being integrated with these simultaneous efforts.
Thank you. I think my colleagues will probably also jump in. So we've been also working with all different researchers who are working in this area. For example, we have the FSM Alliance, and our tool situates in a good position. If you look at the sheet flow diagram that Christine shows, we have tools like sheet flows diagram, which are developed by a lot of the international NGOs and a lot of researchers, and we are working hand in hands with them to see how you can also use Sanipath in all these suites of tools that are all over the place. And Tracy Morse actually also just mentioned that she's using some of our methods in her studies in Malawi and Uganda. Suraja?
Nothing else to add. I think that sounds good.
I do want to quickly add that we have a new sort of branch of Sanipath where we are looking specifically at specific diseases. So we have a Sanipath typhoid project in Kolkata, India, where we do a Sanipath assessment and we test for E. coli, but we're also testing for Salmonella typhi in the environmental samples. So trying to understand specifically how adults and children are exposed to Salmonella typhi through environmental contamination. And the project that Habib described in Ethiopia is actually a Sanipath Campylobacter project where we will be working. This is a collaboration with University of Florida and Ohio State University and Haramaya University in Ethiopia, where we will be testing for Campylobacter in different environmental samples. And then the third example is a Sanipath cholera example that we're doing in collaboration with Dr. Sam Karayuki at Emory in Nairobi, where we will be doing Sanipath assessments in cholera hotspots and testing for Vibrio cholera in the environmental samples. So all of these take the same exposure assessment approach, but you can customize it by testing the environmental samples for a specific pathogen. And I think that's it for my answer there. Over to you, Rebecca.
Thank you, Christine. And with that, I want to close out our webinar together. Again, a very special thank you to Christine, Suraja, and Habib for your time and your excellent presentations. I want to encourage everyone on the webinar to check out the Sanipath website, which has a wealth of resources. You can also send them some specific questions. Also feel free to visit the ProWASH website on the FSN network, where we'll have recordings and PowerPoints from the entire series. Thank you again to all of you for joining us, and we'll be following up shortly. Thanks all.